Hey everyone, in today's video, we're going to be talking about the problem non-overlapping intervals on Leetcode. So the question says, given an array of intervals where intervals of I is equal to start I and end I, return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Okay. So what the question here is a bit appropriately saying is that, let's say you're given a list of intervals like this, okay, and you need to remove some such intervals that are overlapping. What that means is that, let's say you have over here 0 and 3, right? 0 and 3, 0 is the start time and 3 is the end time. But if we have an interval of 2 and 6, right, and 2 lies between 0 and 3, so this means that 2 and 6 are overlapping 0 and 3, right? So we need to remove either one of those intervals so that we can move forward with our problem, and we can remove the minimum number of intervals so that we have a complete list of intervals which are not overlapping. Okay, so over here we can remove either 0 3 or 2 6, right? Let's take both the cases and go forward with it. Let's say we remove 0 3 over here. Okay, if we remove 0 3, right, so what we have now is 2 6, 4 6, and 6 8, right? So if we have these elements now when we go forward in this loop, we'll check whether these two elements are overlapping or not, right? Since over here, right now, both these two elements, 2 6 and 4 6, are overlapping each other because 4 lies between 2 and 6. Again, we'll need to remove either one of those elements, either 2 6 or 4 6, right? So we'll again have two cases to go with it. So let's say we remove 2 6 over here, right? If we remove 2 6, we have 4 6 and 6 8. Right now, 4 6 and 6 8 are non overlapping because they are not overlapping each other. And this end time of one interval can be equal to the start time of another interval. This doesn't doesn't mean that they're overlapping. This means that they're two separate entities, right? So this is a non-overlapping case. So over here, we had to remove two intervals to make this a non-overlapping interval. But let's take another case. If we had removed 4 6 and kept 2 6, right, would that made any difference right now? So over here, if we removed 4 6 and kept 2 6, again, it wouldn't have made any difference because the end time over here is equal to the start time, and it's a non-overlapping interval in our case again, right? So this is again fine. Now let's move on to what we took earlier. In earlier we removed 0 3, right? Now let's right now remove 2 6 and see what will happen. 4 6 and 6 8, right? If we remove 2 6 right now, we see that 0 3 is not overlapping 4 and 6, and 6 and 4 and 6 is not overlapping 6 and 8, which means that we just need to remove 2 and 6 in this case so that it becomes a completely non-overlapping list of intervals. And as you might have understood right now, what we need to do in the question is we need to find the minimum number of intervals we need to remove from this list so that we make the complete list, and list of non-overlapping intervals. Okay, so over here, if we remove 2 and 6, we can make the complete list a list of non-overlapping intervals. Okay, so let's take another example. All right, in this case, just so that you guys understand it properly, okay, so over here we have 0 3, 1 2, 2 6, and 5 6. Right. So let's say we remove over here, let's say in the very first case, 0 3 and 1 2. 1 2 is overlapping 0 and 3. Right. It's lying completely inside. Let's say this is 0. This is going to be a space for 1. This is going to be a space for 1, this comma, and this comma is going to be a space for 2. Right. So these are two spaces that how you can fill it. And 1 and 2 are just lying over here. So 1 is lying over here and 2 is lying over here, right? It's completely getting overlapped inside this array, right? And now what we need to do in this case is, let's just assume you have 0 3, right? Let's assume that you don't have 0 and 3, but you have something else like, you know, um, you know what, let's just run with this example for now. Okay, since in this case 0 and 3, right? Now what we have two possibilities again. We can remove 0 and 3, we can remove 1 and 2, either 0 3 or 1 and 2. So let's remove 0 3 in this case and see what happens. Since we removed 0 and 3, now we go forward and see that we have 1 2 and 2 6. right? Now 2 is the ending interval, end time of one interval, and 2, this 2 is the starting time of one interval, right? Now, since they are not overlapping because they can have the same start, end time, and start time for two in different intervals, so they're not overlapping in this case, right? So again, it's fine. So these two are non-overlapping intervals, and right now we just remove one interval to make it non-overlapping. Now over here in 5 and 6, right? 5 is lying between 2 and 6, right? Which means that 5, 6 is overlapping 2 and 6. We need to remove either one of these two intervals to make it non-overlapping. So let's say we remove 2 and 6 over here. If we remove 2 and 6, we can see that we just need to remove two intervals to make this a non-overlapping interval, right? Now, what if we remove 5 and 6? Again, it's still fine because we have, again, two intervals that are non-overlapping. And in this case, let's say we remove 0, we remove 1 and 2, not 0 and 3. If we do that, okay, again, if we do that, we'll still have to, remove again from 0 and 3 and 2 and 6, because 2, 6 does lie between 0 and 3, because 2 lies between 0 and 3, and 3 lies between, from between 2 to 6. So we will need to remove either one of those two intervals to make it non-overlapping. So let's say if we remove this one, right? If we would have removed this one, then we would have to remove again either one from these two to make this a non-overlapping interval, and we would have to remove three intervals. So this would have made it. So this would have made us to remove three intervals, and we removed more intervals than in the previous search, in the previous iteration. Okay, right. So this is not the right answer because you need to minimize the number of intervals that you need to remove as well. And over here, in this case, if we remove 2 and 6 instead of 0 and 3, we would have still just we would still have a list of non-overlapping intervals, and with the minimum number of intervals removed, which is 2. So this would have been the answer. So this is what the question is, guys. You need to remove the minimum number of intervals in the intervals array so that you can make the problem, so you can make the list a list of non-overlapping intervals. Okay. So this is what the question is, guys. All right. Now let's just let me just zoom this out a bit. Okay. Now to solve this problem, right, we'll have only three cases. Okay, we have three cases on how we need to solve this problem. The case number one is you have non-overlapping intervals. Okay, so if you have an interval of 4 and 6, you have 4, comma 5, comma, this is for 5, okay, and this is for 6, this is for 7, and okay, this is 6, right? So you have 6 over here, and you have 6 and 8 over here, right? So this means that 6 is here, and that other 8 is over here. Okay, this is a non-overlapping interval because you can have an interval with an end time over here with 6 and a start time over here, which is equal, but they're not overlapping in this case, right? So this is fine, and this is a non-overlapping interval. This is the first case. In this case, you don't need to do anything over here, right? You can also have something like this. Doesn't need to be 4, 6. You can also have something like 7, 8. These are also non-overlapping intervals, as you might probably understand it from the sequence over here. It's a non-overlapping interval, right? So this is one case where you have a non-overlapping interval. In this case, you don't need to do anything, right? Now, in the second case, right, when you have an overlapping interval, now how is this overlapping interval being happened is you have 0, 3, 1, 2, 3, right? And you have 2, 6. Let's say you have 2 over here, then we have 6 something over here, right? Over here, the start time, the end time of the first interval is greater than the start time of the second interval, which means that the second interval is lying inside the first interval. Okay, the start part of it is at least that is lying bit inside over here. Right, since they're overlapping, what we need to do is we will need to remove either one of the two intervals. Okay, we need to remove the two intervals right now, any one of the two in this case. Okay, now if we have, let's take the third case now. In this third case, we have a case of 0 and 5, 1 and 3, and 3 and 4. Right. Now, what we need to do in this question, in this case, is what's happening over here is 0 and 5 is, let's say, something very big over here. 1 and 3 is lying in between that. Right. Now, in this case like this, in a case like this, what we do is usually we remove the interval which has the larger length. Right now, 0 and 5 has the larger length, so we'll remove that interval and not the 1, 3 interval. Now, why would we remove the 5, 0, 5 interval? Because the interval which has a longer length can encapsulate more number of intervals inside it. So over here, 0 and 5 can encapsulate 1 and 3, and it can also encapsulate 3 and 4, right? So if we do remove 1 and 3 from this interval case, right, we would still need to remove one of the intervals from 3 and 4, right? And it would it would just increase the number of, intervals you would have to remove from in this case, and it would be 2 in this case. But the minimum number of intervals you could have just removed is 0 and 5. If we just remove 0 and 5, we would have just remove one interval, and would have a case of the minimum number of intervals that would have been removed from this case. Okay, so this is what the three cases of this problem are, guys. And let's just see how we're going to solve this problem right now. Okay, now let's just go up, and this is how we're going to solve the problem. I've already coded it. The very first thing we need to do in our question is we need to sort our intervals. Okay. Now, why do we need to sort them? Because, and we're going to sort them in terms of our intervals in a very first index, right? Now, why do we sort them? Because we want them close to each other. We want the closest indexes. Like if we say 1 and 2, we want the index which is coming like something like 2 and 3, or something with the same interval 1 and 2. Again, like something over here. If you have 1 and 2 three times, we want everything to be sorted so that we can just loop through them in one go, and we can remove the most common elements from all of them. Right. Now I'll tell you how is this getting sorted and why it's getting sorted. You'll understand it properly when we, dry run this code. Okay. Now what we're gonna do over here. Okay, so let's dry run an example. Okay. So to dry run an example, let's take this example over here, and we'll take the sorted version of it. Now when we take a sorted version of it, what we'll do is we'll keep two pointers, L and R. Right. Now L is equal to 0 and R is equal to 1 in this case. Now, what we're going to do is we're going to check if our very first interval, which is 2, right, is greater than or not equal to at least our second interval's very first element. In this case, it is greater, right? So we're going to do the very last statement over here where L of 1 is greater. No, we're not going to do the last one, sorry. So over here, this case is greater, right? Which means that 1, 2 is lying between 1, 3, right? Basically, 2 is lying between 1 and 3, right? So what we're going to do in this case, so basically what's happening over here is we're lying inside this case, right? So what we'll do in this case is we'll just remove the very last element. We'll just remove R in this case, right? We'll just remove 1, 3 from our element, and we'll just increment R by 1 so that we reach over here. And this means that this element is removed from our list, and we'll increment the counter by 1. Okay, so in the second case, now when we are over here, we're going to check for 2 and 3. When we check for 2 and 2 over here, basically not 2 and 3, 2 and 2, we're going to check the very first case. L of 1 and R of 0 are same. Both the 2's are same, which means that it's a non-overlapping interval, right? This was the second case where one overlapped the other, right? This was the second case for us. And this is the first case where these are non-overlapping intervals, right? So since they're non-overlapping intervals, we don't need to do anything, and we just need to increment the counter, both of them, like this, right? And we won't increment any counter. Sorry, we just increment L and R. L is going to be equal to R, and R is equal to R plus 1. Okay. Now when we have 3 and 3 over here, again this is a non-overlapping interval. So this is also this will also lie between the case 1, and we'll probably just have a count of 1 as our output, and we'll just return it as our answer, which is again, you can see count of 1 is our output. But what if we had something like this? What are we going to do in this case? If we had something like this as our question, right? So we have now LR. Okay. Now let's say our L is 0 and R is 1. Okay. Now L is 0 and R is 1, right? So now we'll check if L of 0, so L of 1, which is 5, whether it's greater than R of 0 or not. It's less than R of 0 or not. It's not lesser than that. Again, whether it's greater than R of 1, it is greater than R of 1. So then we just go to the very last element over here where intervals of I is greater than R of 1, right? When that is the case, what we're going to do is we're going to make L equal to our R, and R is going to be plus 1, which means that we're just going to remove 0 and 5 from our input list directly, and we're just going to increment the counter by 1, right? And then we're going to check for these two elements. And when we check for these two elements, we see that it's the count. It's going to be a non-overlapping interval. So we just, don't do anything, and we just move forward in the loop. And when we move forward, we see that our is less than, length of intervals, until less than intervals. When we increment it, it's not going to be less than the intervals. We just break out the loop and we come out. Right. So this is how you solve the problem, guys. So let's just run the code. Yeah, and let's submit it. Yeah, it's submitted, guys. All right, guys, this is how you solve the problem. And if you like the video, do like, share, and subscribe. And do write in the comments what you liked about the video and what kind of videos you want next to the channel. And until next time, guys, thanks for watching.